In Workplace and Apprenticeship 30, this is section 5.2. We're just starting. This is video number 1, lesson number 1. We're going to take a look at quadrilaterals here. So we're working with parallel lines, transversals, quadrilaterals. Do you guys know what quadrilaterals are?
Four-sided figures.
Yeah, quadrilaterals are four-sided figures. And you could close that door, maybe force to. So four-sided figures. That's right, quad. Quad is the word for four. So the first thing we need to learn, and this might be a brand new word for you, but while we have parallel lines, which shouldn't be new, parallel lines are two lines that would never intersect, right? They're always the same distance apart from each other as they run kind of alongside each other. Those are parallel lines. But if we have two parallel lines and a line that crosses both of them, a straight line that crosses both of them, that's called a transversal. So I'm just going to zoom in here, transversal. You want to write this, you want to write that down in your notes, okay? A transversal. A line that intersects two or more lines at two distinct points. And I did mention parallel lines. Most of the lines we're going to be talking about will be parallel, but it's basically a line that crosses two or more other lines, okay? And I will just put this here. What should I put here? We're going to be mostly dealing with parallel lines. So I'll say usually parallel. Usually parallel. So a line that intersects two or more lines and at two distinct points would be the complete full definition there. And usually parallel lines are what we're going to be dealing with. All right. So what that brings us to then is this diagram down here. And if these lines right here are parallel, then we have some special things happening. But even if they aren't parallel, let's talk about some of the special things that a transversal creates. So if I have this line right here, line 1, and T, the transversal, intersects at this point, if this is 75, this angle right here, okay, what we know is that angle 1, we can figure out right away what angle 1 is. Because angle 1 plus angle 2 have to add up to what? You guys know? 180, right. So a straight angle, that is an angle that opens up all the way so that the two lines form a flat line or a straight line, that's 180. So yeah, so we can say that angle 1 and angle 2 here are supplementary. There's a special name for them. And you may remember this as well, but the next definition you want to write down is supplementary angles. So two angles that add up to 180. Two angles that add up to 180. Okay. So there are lots of pairs of supplementary angles in this little diagram. We already said angle 1 and 2. Well, angle 4 and 3 are supplementary. You can kind of see that, right? Also, angle 6 and 7 are supplementary. See that? What about angles 1 and 3? Are those supplementary? So what's the relationship between 1 and 3, do you think? Yeah, they're the same size. And these are called opposite angles. Sometimes they're called vertically opposite. I'm not sure if we're going to get into that here this lesson yet, but these 1 and 3 are not supplementary. Anything that crosses the vertex or the intersection point, if you go right across, those are the same, not supplementary. So these would be 1 and 2 are supplementary and 3 and 4 are supplementary. Good. Okay. All right. Any questions there so far? All right, well, what else do they want to tell us here in 5.2? Okay. All right, so we're talking about, now if we're talking about parallel lines, okay, then some more things can be determined. So let's go back, let's go back to this diagram. And let's pretend, or let's assume that these are parallel lines now. Okay, line 1 and line 2 are parallel. Now, this is going to be really important, and you can jot this down if you want, or you can just sit and listen for a minute. if these lines are parallel, they'll probably be indicated parallel by an extra little arrow on each line. And so if we have an extra little arrow on each line, that means they're parallel. Okay, so it means that angle 2, let's say, this angle right here, and angle 6, okay, are what? What do you think those look like? They're buddies, okay, yeah. Would they be supplementary or would they be equal, do you think? Yeah, they're equal. It probably wouldn't take too much to understand that, hey, these are the exact same size angles. If I draw that, it might look exactly the same, right? So if these lines are parallel, it's kind of like they're the same line almost. If you just were to slide this line up, it would be the exact, it would lay on that line exactly, right? It would map right onto that line. So if you took the same line and you just shoved it down so that you had two parallel lines, then this line would be equal to that one, or angle. Now, what angle is equal to number 1? Name me one. There's a few. What angle is equal to number 1? Did you say this? 5? Who would agree that angle 1 and angle 5 are equal if these lines are parallel? Yes, no? Agree? Okay, that is correct. What's one other angle that's equal to 1? Another one. 3, yep, 3. Okay, maybe I'll leave this one here. So angle 1 and 3 are equal, angle 1 and 5 are equal. What's another angle that's equal to angle 1? 7, yep. So 1 is equal to 3, and 3 is equal to 7. And so 1 must be equal to 7. See that? So yeah, all these are equal. 1, 3, 5, and 7 are equal. Now if I use a different color, angles that are equal to 2 would be, well, 4, 6, and 8. Does that make sense? So who can be the first one to tell me what is the size of angle 5? What's the size of angle 5? 105. I got it over here first. Nice one. Now angle 5 we said was equal to angle 1, and angle 2 and angle 1, what's the special name between angle 1 and 2 again? Supplementary. So that means that 180 minus 75 is angle 1. And because angle 1 is equal to angle 5 is also 105. And angle 7 is 105. Okay, very good. Here's a question, I don't think we talked about these ones yet. What's the relationship between 3 and 6? 3 and 6. Okay, yeah, that's good. You remember the name of them. The name of them, they would be same side interior. So they're the same side of the transversal, and they're also inside the parallel line. So that's same side interior. I don't know if we have to name those just yet, but that's very good that you remembered that. So what's the relationship between angle 3 and 6? Are they equal, supplementary, or something different? Do they look equal, first of all? No. This one is acute, angle 6, and this one is obtuse. So let's think about this. 2 and 3 would be supplementary. 7 and 6 would also be supplementary. If angle 3 equals angle 7, then angle 3 and angle 6 would be supplementary. Yeah. Angle 3 and angle 6 are supplementary. Okay, very good. Okay, one more that I can think of that I want to tell you right now. Angle 4 and angle 6. What's the relationship there? They are what? Now, so far it's been equal or supplementary, right? They are equal, is correct. Yeah, they're equal. Okay. Any other questions you guys have for me right now? No? I understand. Okay, good. Okay, so far this is going pretty good. Now, there'll be other things that will come up as we move along. So what I want you to do is I want you to copy out this diagram, please. It doesn't have to be perfect, just 2 lines there, line 1, line 2, and then 2 transversals. And line 1 and line 2 are parallel. So we're going to work through this and see if we can identify what the angle measures are in these ones. So I'll give you a second to copy that down. So as we look at this strange figure, we do know that line 1 and line 2 are parallel. So we're just going to make that notation there with an extra set of little arrows there. They're parallel. Okay. So I'm looking, the first thing that jumps out at me is this pair right here of angles of 120 and number 4. So what did we say was the relationship between angles that look like this? They are supplementary. That means they add up to what? Right, to 180. So 120 degrees plus angle 4 equals 180. So angle 4 is going to be equal to 60 degrees. Very good. That's angle 4. Okay, angle 4. All right, so we've got angle 4 taken care of. And again, you know, showing your work, like this would be perfect for showing your work. That would be, I would completely understand what you're saying there, and I know that you know what you're doing when you show something like that. Okay? So don't be afraid to jot down a few lines of work when you're doing your reasoning. All right. Now, I see I have parallel lines 1 and 2, and I have a transversal over here as well. Okay, so let's take a look at angle 110 here, and this one. Now, in our previous diagram, what did we say those angles were? Were they equal or supplementary? They are on the opposite side of the transversal, and so they are equal. Yeah. So angle 1 is 110. Okay. Now, a reasoning here, yeah, I get it. Sometimes it's a little tough when they're equal. And again, we haven't really named these angles yet. These would be alternate interior. So there are same side interior angles and alternate interior angles. And it is a law, a rule, that alternate interior angles are equal. Okay? When the lines are parallel and cut by a transversal. So I'm okay for number 1 to say angle 1 equals 110. Okay? Now, what about, what's another one that we can figure out? So I'll let you guys think, but we need to get 3 and 2. So how do we figure out one of those? What jumps out at you there? Anybody?
Same side interior.
Okay, same side interior?
4 and 3.
4 and 3. No, 3 is not interior.
Exterior.
Yeah, so okay, so let's focus on number 4 and number 3. So these lines, remember line 1 and line 2 are parallel. This is a transversal. So do these lines look like they're supplementary or equal? They are equal. These are called corresponding angles, corresponding. And yeah, if these lines are parallel, then 4, so angle 4 equals angle 3, which equals 60. Okay? And that's 100% true. Corresponding angles. Okay. We'll summarize some of these names a little bit later here, but that's what we're looking at right now. So I guess number 2 is the only other one that we have to figure out. Now, is angle 1 and angle 2, are they equal? Or is there a relationship there between 1 and 2? You guys are kind of like thinking no. They're 2 different transversals, so we can't really compare the angles around one transversal with the angles around another.
Well, they're 2 same transversals.
Sorry?
Well, they're divided by the same transversal. Oh, angle 1 and 2. Oh.
Well, angle 1 and 2, okay, so these lines are not parallel. This could be a transversal, but there's no real relationship because those lines aren't parallel. So we're not going to compare 1 and 2, but we could go with 3 and 2, right? Or we could, and this is another thing that might jump out at you here, is that 120 and number 2 are also corresponding angles, and they have to be equal. Okay? So angle 2 equals 120 degree angle. And also you could say angle 3 plus angle 2 equals 180. We already know that angle 3 is 60, so 60 degrees plus angle 2 equals 180. So angle 2 is 120. Okay? So it looks like we have angle 1. Did I really not write that, or did it get erased? 11? 110. I actually don't know if did I actually write 110 and I erase it, or did I only write 11? Anyways, wow, that was weird. Okay, so 110. Angle 2 is 120. Angle 3 is, oh yeah, right here, angle 3 is 60, and angle 4 is also 60. Okay. So we've done that entire diagram there, okay? Any questions about that? That's the first build your skills question. So this one's a bit different, but if you kind of understand what we're doing so far, you might be able to answer this. So let's answer this one together. And you can take a moment to copy this diagram down. And if it's saying that if angle 1 is parallel to angle 2, then what must angle number 1 be? Okay, so take a moment to write that down and see if you can tell me what that is, and I'll check back with you in a minute. All right, does anyone have an answer for what angle 1 must be? 123. You guys get 123 as well? Okay, let's see. So this appears to be, well, if I say this angle right here has to be the same as angle 1, that's the same as angle 1. And then I know what the relationship between these two angles are, 57 and this. They have to be supplementary. So angle 1 is 180 degrees minus 57 degrees, because they're supplementary. Angle 1 and 57. So what did you say it was? 123? Okay, that is correct. 1, 2, 3. It's as easy as ABC. No. Easy as 1, 2, 3. I guess it's not easy, is it? It's as easy as ABC. Okay. Okay. You guys are funny. All right. So, yeah, you're funny. Frozen? Frozen. Frozen 2. Oh, look at that. Okay, we're going to round off this lesson by talking about some quadrilaterals. So let's write down the definition for a quadrilateral. And that is a four-sided polygon. That's just a fancy name for a closed figure with straight sides. Okay. A four-sided polygon lying on a single plane. Okay. All right. These are pretty specific definitions. A single plane. Okay. So, all right. So a plane, we're talking about a plane of space, like a two-dimensional slice of space, okay? Like this slice of space is a two-dimensional plane. This is another two-dimensional plane. This is another two-dimensional plane. So all four sides are lying in the same plane. They probably didn't really need to do that, except if you consider this. Let's say, okay, see my pens here? You can. This is going to be really tough for me to do, actually. But if I've got four, let's say I've got four. This is a quadrilateral. Okay. Now these two sides are in the same plane. Okay, they're in the same slice of space there. This third and fourth side could be angled like this. You see, they're not all in the same plane. You see, this is still three-dimensionally. It's a three-sided figure, but all the sides are not in the same plane. They would have to be all in the same. Oh boy, how do I do this? They have to be the same two-dimensional plane. So there's one plane here, and here's the other plane. They have to be in the same slice of space. That is what we're talking about, okay? Not something that's like bent like this. So two of them are in one plane and two of them are in another plane, okay? Does that make sense? I mean, technically, that's technical. That's very good. Okay, so what are the types of quadrilaterals? Let's take a look at this. This is going to be great, and I have actually an exciting activity for you guys to do regarding these quadrilaterals. So what we need to do is, first of all, I need you to draw each type and label it and explain it, okay? So you have these in your notes. And the time that you're going to take to do that is going to help you remember them. So quadrilaterals are four-sided figures. So one type of quadrilateral is, or one category would be the parallelogram. The parallelogram. The parallelogram has two pairs of parallel sides. So opposite sides are parallel. They don't have to be straight up and down. They could be slanted, but they're going to be parallel to each other. And the other sides are also parallel. Okay? They do not have to all be the same length, though. Okay? But let's talk about that. Okay? One type of parallelogram is a rectangle. That's a parallelogram. So I would encourage you to draw this sort of chart here, or at least put parallelograms and rectangles kind of together in your notes. Okay, a rectangle. And a rectangle has 4 right angles. So that's when the sides are straight up and down, and then straight, side to side. We know what a rectangle is. And a rectangle, the sides are not necessarily equal either. A special type of rectangle that also has 4 congruent sides is called a square. So this should be pretty easy. You write this down? You drawing all these? Okay, and you've got this written down as well? 4 congruent sides, okay. Yeah, you don't. Okay, good. Do that now, please. Thank you. All right, what about this one here? Look at this. A rhombus. Okay, so this one is a little lesser known. I got to tell you a story about a rhombus. I tried to get home the other day. I didn't have a vehicle, and it took me 3 hours to get home because I took the wrong bus. Did you guys get that joke?
Yeah.
I didn't have a vehicle, and it took me hours to get home because I got on the wrong bus. I didn't get on the right bus. I got on the wrong bus. Yeah. Funny? No. Okay. And then this guy said to me, "Dude, you on the wrong bus, man." And then what happened? Then I got off and got on the right bus. The right bus is not a parallelogram name, unfortunately. It's too bad. It would have been a greater story. Okay, but a rhombus is a rhombus. The rhombus. It's not a rhombus. I want to call it a rhombus now, but the rhombus is 4 congruent sides, but we do not have right angles. Okay? They're all the same length, but we don't have right angles. Okay? Now I threw you off with that story of the rhombus. Okay. Let's keep going. Okay, parallelograms. Now, here's another type of quadrilateral. It's the kite. This is a special one, and I bet you don't know why it's called a kite either.
Because it can fly.
Because it can fly. I'm not sure if it can fly, but it is shaped like a what? A kite. Yeah. Well, a diamond, now that's interesting. A diamond, not necessarily a diamond. Let's just take a look. We have 2 pairs of congruent sides. I think a diamond would be more like a rhombus, really. All the sides would be the same. Do you think? Maybe? I think a kite would be a little different than a diamond, I think. But see, the kite has 2 pairs of congruent sides, and the diagonals intersect at 90 degrees. So this is different than what we're going to learn next, a trapezoid. It's a kite, so it looks just like this. So these 2 sides would be the same, these 2 sides would be the same, and they're positioned in such a way that the diagonals form a right angle. And yes, a kite that you fly, like the old school kites, were this shape, with they had the little dangly thing, right? Had the little string like this with the little knots in it or whatever is in there, Okay.
Sorry for the interruption. This is the last call for international students and buddies. If you're planning to go to the student.
Okay, so the third category is the trapezoid. Trapezoid. Now this is not a kite, right? Because look at these diagonals. If you were to draw the diagonals of a trapezoid, they would not intersect at a 90 degree. Plus, a trapezoid, the big thing about a trapezoid, okay, is that opposite sides are parallel. There's 1 pair of parallel lines. 1 pair. That's a trapezoid. Now there are 2 types of trapezoids. The right trapezoid. No, you're not going anywhere yet. Grade 11s can quietly leave, but grade 12s need to stay with me. The right trapezoid has 2 right angles. So you guys are writing this down, right? You got this down? You got to write all this down. You got to write all this down. Get your stuff up. Right trapezoid. Isosceles trapezoid is a trapezoid where opposite sides here, not the parallel lines, but the other sides, the opposite, are the exact same length. You need to have all this written down before you leave. You got it? Okay. Now, I will tell you what your assignment is that you need to start. Okay, are you ready? This is your assignment. Your assignment, write this down real quick, and I will give you time tomorrow to work on this. Okay? But your assignment is to draw a picture. Yes, we're doing some artwork. Draw a picture of some scene using only quadrilaterals that you see on this page right here. The entire scene has to consist of quadrilaterals. Got it? I will give you time to work on that tomorrow, but I need you to start thinking about that. You can even start sketching that out, but that's your assignment for this lesson.